Hi, welcome to Chem 109, General Organic and Biological Chemistry. I'm going to be your instructor, Dr. Adams, and I'm excited to begin working with you all. We're going to start off with our Chapter 1, and thank you for watching the pre-lecture video. You should watch Chapter 1.1 and Chapter 1.2 before the first class period and read the associated material in the textbook, which is a really good source. It always worked for me to thoroughly understand and read what's in the textbook. And we're going to go over some practice problems that are in the textbook as well. So a lot of repetition is really going to help you to retain the information. Okay. So we're starting with 1.1. We're starting broad, okay? Matter, that's everything, right? So everything takes up space. We're going to break down matter into pure substances and mixtures. And then we're going to talk more in chapter 1.2 about some of the jargon that we're going to go over in 1.1, elements, compounds, and the periodic table. Okay, and the periodic table can be found at the beginning of that really awesome textbook that you have. We're going to start by talking about matter. So what is it? What's matter? Anybody who've already read the chapter can answer the question. See, it's anything that takes up space. So that's one of the major characteristics. It has volume, or it weighs something. It has mass. And it'll help you to draw this out, rewrite everything to reinforce that knowledge, okay? And so, or come up with some sort of acronym that helps you to remember that. Okay, so matter is anything that takes up space and weighs something, right? So look, see, I'm going to write it out, matter. So let's see, it has volume and mass, okay? So you have to stay on top of this. Make sure you keep up with the definitions as we go. Here we have this nice table that's going to help us to classify what chemists talk about as matter, right? Anything that what has volume or mass. It's broken down into two major groups, pure substances and mixtures. Okay, so let's start with pure substances first. We have elements. This is what you find on the periodic table. You probably remember that from high school. And we're going to have compounds. But elements are the simplest form of matter. So here we're talking about one element. And examples, and the book gives you a lot of examples, help you to apply this to the real world and what you already know, making chemistry and biochemistry really interesting, right? It's life unraveled. You can see it here. We're breaking down everything. We're breaking down matter. So when we're talking about the simplest thing, and we're going to give a written definition for an element, don't worry. We're talking about elements, and you already know some of those. Sometimes your favorite element might be gold, okay? And that's represented by this chemical symbol from the periodic table that's derived from Latin, okay? So you're going to have to remember some of those, but most of them are based on you know, what we know as far as English goes. English spelling's hydrogens. The chemical symbol here is H, right? So as long as we have an element, whether it's one atom, like one atom of gold, or two atoms of hydrogen, because we have hydrogen that likes to covalently bind to hydrogen. Some of the other favorites like oxygen would do that too. That's classified as an element. A compound is when those elements are compounded, right? Here we have hydrogen and oxygen. Okay, that's water, where we have those hydrogens bound to oxygen. And that compound, water, that chemical formula, those symbols put together and make that chemical formula, that's gonna stay the same no matter where you go. Water is water. Okay, it's always H2O. right? And similar with table sugar, your C12H22O11. And here you have aspirin. Okay, that's not a tablet, that's aspirin. That's a compound. That's the same no matter where you go. And then we're going to look at mixtures, okay? So we went from simplest, and we're getting a little more complex. We have our mixture where we have homogeneous mixtures, or homogeneous, whatever you prefer to say it is fine, as long as you know what it is. It's fine with me. And heterogeneous mixtures. And one example of a homogeneous mixture would be sugar water. Why? Because here you see we're building up, all right? We have water, which is a compound, and we have sugar, which is another compound, and we mix them together, right? That's a mixture. And what happens whenever you mix them together, all right? You have your glass of Gatorade that you're getting ready for your football game or your softball game. And here you have your Gatorade mix. See, there are clues everywhere. Gatorade mix. You're going to put that in there. It's going to dissolve. And the whole thing is going to look blue. So it's a mixture. You can't pick out and see the sugar, right? It dissolves. That's a homogeneous mixture right there. It's got this uniformity to it, right? It is uniform. And we talked about aspirin earlier. The aspirin tablet is not just aspirin. There are other things there, like cornstarch as a binder, water, stearic acid, somebody that is made by someone or some machine in a pharmaceutical factory. And so this is another homogeneous mixture. We have this heterogeneous mixture. An example of that would be a fish tank. And that's a good example here from your book. And you'll be able to think of your own examples. But why is this a heterogeneous mixture? Well, you can see and pick out the parts very easily. You can see those differences, okay? You can see the pebbles. You can see the fish. You can take the fish out of the water, although maybe you shouldn't, right? So you have vegetable soup where what do you have in there? You have some turnips, some potatoes. Might be hard to tell the differences between those, but this is vegetable soup, right? You can see those components. You can pick them out. This is a heterogeneous mixture. So you can see, you can pick it out. These are good examples. And like I said, you can start coming up with some of your own, but your book has some good examples. And once again, we'll be a little repetitive, but that's good. It'll help reinforce, right? Matter is what? Anything that has volume and mass, okay? And so anything that has volume and mass, that's including pure substances, which are, one of the major categories of matter, and mixtures, okay? Those mixtures have volume and mass. Another way to think about it. I'm not sure why this slide is wacky, but I think it's normal on Moodle. And we have the pure substances that include elements and compounds, and mixtures, homogeneous mixtures, heterogeneous mixtures. Sometimes you just need to take a bigger view, step back. That's why those diagrams are good. And they are, something that you can build off of and write down your own examples. You can draw them out. And while we're moving along, if you want to stay on top of things, you need to stay on top of your jargon, and you do that by building up your vocabulary. And you can do that with these simple definitions and that are on these slides and that are in your textbook, right? Because these slides are straight from your textbook, right? They're from Pearson. We have pure substances and mixtures. Okay, we need to be able to really not just draw a diagram. You have to know what you're talking about on that diagram. A pure substance is matter that is made up of only one type of substance, and it can be represented with one chemical formula or symbol. Okay, those chemical symbols, all right, the elements on the periodic table, and the chemical formula. So here you remember like your elements that we were talking about, like, iron, that's a good example. There's an element. Or you have a chemical formula, like you have a compound, you have water. So, all right, make sure while you're understanding the definitions, you can come up with an example. An element is the simplest type of matter. It's made up of only one atom, okay? One type of atom. But if there's more than one, like you see here, that's classified like here. This is an element, okay? An atom, okay, is the smallest unit of matter that keeps its unique chemical characteristics. So you can get smaller than that, but you won't keep the unique chemical characteristics. And so an atom is really interesting and is very unique. Okay, the smallest unit of matter that keeps its unique characteristics. And a compound is a pure substance. So compound, it's not a mixture, it's still a pure substance made of two or more elements. So that's the big distinguishing factor between just element and compound, right? One element, one type of element, or compound, okay? Got it. And now we'll talk a little bit more about the definitions for mixtures. You see here we have mixture is a combination of two or more substances. Okay, substances. Now we're talking a combination of two or more substances. And a mixture can be separated into its different components, okay? Like we have earlier, we talked about sugar water. So here, let's talk about salt. So we add our salt to the water. But if we heat this, like if this is, a little boiling pot, and we're going to apply some heat, the water is going to evaporate, and we can separate these two quite easily, right? And so a mixture can be separated, all right, into its different components. But that mixture, can be broken down further into homogeneous and heterogeneous mixtures, because homogeneous mixtures have this uniform composition. It's the same throughout, just as I talked about the blue Gatorade, for example, right? The whole thing is going to appear blue, right? Pretty evenly. So that's uniform. All right. Whereas if you have, so these are examples here. These are homogeneous. But here is heterogeneous mixture. If we put sand here, like if you've got a bucket of water at the beach and sand, you might be able to swirl it around, but eventually, right, that sand is going to settle at the bottom. And so you can see those two pieces, you can separate them out, right? You can see those components, you can see the differences. You can see the parts here. So this is a heterogeneous mixture. So that's not what uniform, right? In composition. So we have our diagram once again, just to remind us and give us more examples. I said the book is very thorough. We have our elements, like you see here. We have our copper atoms, okay? So that's an element made of atoms. Here, that's one element. We have our compounds. This is more than one element. More than one element. Okay. So here we have, once again, our water molecules. And we have a mixture. if you look at a trumpet or a French horn, something that is made of brass, all right, you know, brass is not an element. It is not a compound. That is a mixture of substances of copper and zinc atoms, okay? But you can't really just see individual copper and zinc, right? This is a homogeneous mixture. Here, like if you put pennies in this water, this is a good example right here. You can see that the copper does not dissolve in the water. You know, this penny sink to the bottom. You can clearly distinguish the water from the copper pennies, right? Okay, so that's a good example, right? So we're going to save 1.2 for the next video, and we're going to work some in-class problems. And we're going to go over some of the odd examples like 1.1 and 1.3, and you're going to do the even ones at another time. And starting with 1.1. So we're going to work 1.1 first. And the question says, or the problem is to classify each of the following substances as a pure substance or a mixture. Okay, pure substance, mixture, got it. First, we have A, iron, that can be written with this chemical symbol. That's, you can have, you know, 1 atom of iron. This is on the periodic table of elements. And an element is classified as what? A pure substance, right? So this is a pure substance. And we have B, gelato. So that's an Italian ice cream. Okay. So what goes into this delicious concoction? We have sugar, we have cream, we have some sort of flavoring, right? That's obviously what, and I said concoction, so there's another hint, right? This is a mixture. Okay, pure substance here, mixture B, C, cinnamon. So what is cinnamon? It's a plant compound, right? So this is, a plant product. It's not a plant compound, but plant product, excuse me. Plant product. And it's composed of what? It's not just one thing, like you might think. It's going to have what anytime something's a plant product? Cellulose. Going to be some other proteins there. So this is what? This is definitely got to be a mixture. And D, spring water. Now I know I said that the compound H2O is the same no matter where you go. That's water is always going to be H2O. Spring water, this is not deionized distilled water. It's just coming from a spring. It's coming from the ground. So do you think that that's a pure substance as in a compound, or is it a mixture? Was it just water? No, it's not. But you're going to have some dirt. You're going to have maybe some worms even. In reality, you're going to have some minerals, right? You're going to have, maybe like some bacteria or some amoebas in there if it's like straight spring water. One way or another, this is a mixture. Okay, it's definitely a mixture. So of these, A was your pure substance. Okay, you can see the difference there. 1.3, let's read the problem carefully. Classify each of the following mixtures as homogeneous or heterogeneous. Briefly justify your answer. Well, the bowl of vegetable soup That is, one of the examples that was given in the book. Can you pick out the pieces of a vegetable soup, right? That's one. Can you see the differences? Like, yeah, you can. You can see that this is not uniform. You can see the carrots and the noodles and the turnips. This is definitely heterogeneous mixture, right? And that can be justified easily because it is not uniform in that composition. Mouthwash, okay? Think about mouthwash. If you're just looking at it in a clear glass, it could be mistaken with that Gatorade example, right? But you wouldn't want to drink mouthwash, obviously. So what's in there? Alcohol, right? There's a lot in there that, there's going to be some alcohol, your sterilizer, some, I don't know, some spearmint or probably some artificial flavorings. This is definitely, you have a homogeneous mixture here, okay? Why? Because can you see that alcohol? No, you can't see and differentiate all the flavors and the alcohol. It's just one consistent thing. Okay, so this is uniform, and that's homogeneous. Okay, we have an unopened, let's say, bottle of cola so that you can see through it, like a Dr. Pepper or something, a big 2-liter of Dr. Pepper. You have this brown liquid throughout. So what do you think that is? Right? And you ask yourself those questions. What do you think? Can you see some differences there? Can you see the sugar that's in there? No, you cannot. This is uniform, and therefore, in chemistry jargon, we say that is heterogeneous. A dinner salad, well, think about it. Can you see the banana peppers that you don't want in there? Yeah, you can, and you can take them out really, really easily because you can see them. You can just pick them out with your hands, in fact. And so, oh, I wrote this wrong for C, sorry. This is a homogeneous mixture. Whoops. So this uniform is homogeneous. Okay. And a dinner salad is what, C? If you caught that error, that means you were paying attention. A dinner salad, that's a heterogeneous mixture, right? Because you can see those things. You can see those peppers. You can take them out of there. That's not uniform in its consistency. Okay. So we have heterogeneous, homogeneous, homogeneous, and heterogeneous. Okay, you can see the differences. Not uniform, 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 not uniform, right? Makes sense? Okay, we're going to save chapter 1.2. So that's it. Thank you for tuning in.